Hello everyone, this is Dr. Shashidhar from Bennett University, Greater Noida, India. In this video tutorial, I will teach you the consensus protocols and the blockchain platforms we have. Okay, so let me discuss the problem, double spending problem first. So in the traditional banking system, so if you want to transfer a digital money from one wallet to the another wallet, the bank will verify. So here the bank will act as a third party entity, and before initiating the transaction, the bank so like it verifies the wallet. So whether we have a sufficient balance. If we have the sufficient balance, then only we can make the money transfer. Okay, so in the blockchain network, so the blockchain network is designed based on the uh, proof that no intermediaries, like no third parties will be there, right? So now who will verify the transactions in the blockchain network or in the Bitcoin network? Here we have a scenario like double spending. Now here in this scenario, A is going to send the bitcoins of 50 to B as well as C at the same time. Okay, so who will verify this? Okay, so this is double spending. So this is invalid transaction. Now who will verify in the blockchain, because there is no third party entities. Okay, so for that solution we'll discuss. Okay, so after that we will discuss the consensus protocols. Okay, so here we have a sentence: in a centralized system, the bank prevents double spending, obviously. Now how can we prevent double spending in a decentralized network like blockchain? Okay, now we'll see the solution. Now, how to handle the double spending using blockchain? So we know that details about the transaction are sent and forwarded to all as many other computers as possible in the blockchain network. So here blockchain is a constantly growing chain of blocks that contain a record of all transactions. The blockchain is maintained by all the nodes in the network. Everyone will be having a copy of the blockchain to be accepted in the chain. So if any transaction to be accepted in the chain, the transaction block must be valid and must include some proof of work. So it is computationally difficult hash generated by the mining procedure, that is in order to solve the cryptographic puzzle by the miner, then you can add the proof of work. Now the blockchain ensures that if any of the block is modified, all of the following subsequent blocks will be recomputed. So it is highly impossible to modify the data that present in the blockchain network. Okay, so now we are discussing about the double spending problem. So the solution for double spending problem is proper validation. Validation. Okay, when multiple valid continuation to this chain appear, only the longest such branch is accepted and then can be extended further. So if you want to add a new block into the blockchain, there is a rule called longest chain. So that is there. Okay, so then the validation prevents double spending in the Bitcoin or blockchain network. So because where she got the 50 bitcoins at the starting, where she is sending the 50 bitcoins. Okay, so like every node will be having that particular record. So others has to confirm the transaction. Okay, so once she is transferring the coins, bitcoins A to B, 50 bitcoins, that should be confirmed by other nodes in the blockchain network. So then only that is a valid. Once she has transferred, that is unconfirmed transaction. When we can say that the transaction is confirmed after confirming the nodes, particular nodes in the Bitcoin or blockchain network, then it is confirmed. So like that, by using the proper validation, we can avoid the double spending problem in the Bitcoin blockchain network. Okay, so now we have the concept of consensus. Okay, so consensus algorithms or consensus protocols. What is it in blockchain? Okay, so here let me define the consensus. Here the blockchain technology allows all the network participants to reach an agreement that is known as consensus. Okay, so here if you want to take any decision in the blockchain network, all the nodes should agree on that decision. So it's like a common agreement between different nodes or different blocks on the blockchain network. So it's like a procedure to reach in a common agreement in a distributed networks or in a decentralized networks. So these consensus mechanisms are very important for the message passing systems in a distributed environment. Okay, so here we have a question. Why we need consensus protocols? So here is the answer. So in order to ensure the reliability and fault tolerance. In a distributed system, we can use consensus. So ensure correct operations in the presence of faulty individuals. If there are some faulty nodes in the blockchain network, so how to deal with that with help of consensus. So here the example like commit a transaction in a database, state machine replication, clock synchronization. So these are the examples. So in these cases we need a consensus protocols. Okay, so let me discuss some distributed consensus. So there can be various types of faults in a distributed system. Okay, so we know the distributed computing system or a decentralized computing system. Okay, so we'll be having many faults. So like a crash fault. Okay, so a node suddenly crashes. Okay, so if a particular blockchain node will be crashes, then who will validate the particular transaction, and it becomes unavailable in the middle of a communication. Okay, at the time, how to deal with that? That is also the problem. And we have one more fault like network or partition fault. Okay, so a network fault occurs, say the link failure, and the network gets partitioned. At the time, what we have to do? So here it's like the blockchain is based on the majority voting, and other nodes has to give the confirmations in order to confirm a single transaction, or in order to add a new block. Okay, so other nodes has to validate. Okay, so suppose there may be a network fault, some part of the network will goes down. At the time, what we have to do? Okay, so here again the consensus will come into the picture. Okay, so even there may be a nodes like Byzantine faults. So here in the Bitcoin nodes, even there may be a Byzantine nodes. All nodes are not true. So we cannot say that all the blockchain nodes, blockchain users, blockchain miners are true. So few nodes will behave as malicious. At the time, what decision has to be taken by the blockchain network? So these problems can be sorted out using the consensus protocol. Yeah. So you can see that the purpose of consensus protocol. So like correctness of a distributed consensus protocol, which ensures the safety. Okay, so here correct individuals must not agree on an incorrect value. So like nothing bad happened. And also liveness. Every correct value must be accepted eventually. Like something good eventually happens. So like these properties we can ensure by using the consensus. So consensus protocol ensures safety as well as liveness in the blockchain network. So here we have a list of objectives. So these are the objectives of consensus protocols. Okay, so the objectives of the consensus protocols is like coming to an agreement, collaboration and cooperation, equal rights to every node in the blockchain, and the mandatory participation of each node in the consensus process. So whenever there is a validation comes, so most of the nodes, so it is compulsory or mandatory to participate in the consensus process or validation process. So, a consensus algorithm aims to finding a common agreement that is win for the entire blockchain network. So here we can consider a problem like Byzantine generals problem. So what is the meaning of Byzantine? Faulty. Okay, so malicious. We can say that Byzantine. So here Byzantine general problem. Consider a message passing system. So here general behaves maliciously. So like the scenario is like, okay, let me define the Byzantine general problem. So here there are four generals. So we can say that the commanders in an army. So they are located in four different places. So they want to attack on some particular enemies. So here in the army there are general, or we can say that the majors, they will be located in four different places, and they want to attack on some enemies. At the time they should message passing should be required. They need to exchange the thoughts and ideas and about the situation, whether we need to attack on the enemies, otherwise we need to withdraw. Okay, so here you can see that there may be a four majors. They will be in different locations. Here the all the people who are exchanging the messages. Okay, so through a wireless communication or wide communication, okay, they are exchanging the messages. Here one general or one major will be behaving maliciously. So like all others are telling that, so the condition is okay, we can attack on enemies, but one major or one general is telling that retreat, so withdraw the attack, so the condition is bad, like that, because he is behaving maliciously. So like all nodes are uh, uh, not same. So like one person will be the Byzantine. So he is the Byzantine now. So this scenario can be applicable to the blockchain network. Okay, so blockchain network consists of number of blocks. So there may be a some faulty blocks also will be there, right? So how to avoid that faulty blocks? Okay, so there may be a false will occurs. Okay, so because few nodes will behaves maliciously. Now, this problem can be Byzantine generals problem can be avoided using the consensus protocol named BFT, that is Byzantine fault tolerance. So this is one of the feature of distributed network in order to reach consensus even when some of the nodes in the network fail to respond or respond with incorrect information. So in the previous scenario we have discussed, so while exchanging the messages due to the network failure, so the messages may be lost or few nodes will behave maliciously. So at that time we can use this consensus protocol, Byzantine fault tolerance protocol, in order to avoid the Byzantine generals problem. Okay, so the objective of BFT, the objective of BFT mechanism is to safeguard against the system failures by employing collective decision making, which aims to reduce the influence of the faulty nodes. So this is the objective of Byzantine fault tolerance consensus protocol. Yeah, next we have uh, protocol like proof of work. So this is also one of the consensus protocol. So the proof of work protocol can be used in Bitcoin. Okay, so here the central idea behind this algorithm is to solve a complex mathematical puzzle and easily give out a solution. Okay, so this mathematical puzzle requires a lot of computational power, and thus the node who solves the puzzle first will get the mind the next block. Okay, so like based on the proof of work. Okay, so this is one of the protocol, consensus protocol used in the Bitcoin network. Now in Bitcoin network there is a concept like solving the cryptographic puzzle. So here the miner has to find a nonce value. Okay, the miner has to find the correct nonce value. In order to find that nonce value, the miner has to produce some proof of work. Okay, so you will use the dedicated hardware or system resources in order to find that nonce value. So that is called proof of work. Okay, with help of the proof of work, so you can prove the validation of the transactions by giving the proper nonce value. Then the block can be added into the blockchain. So that is proof of work. So here the miner who will introduce us the block, they will get the reward in terms of Bitcoin. Okay, so one more protocol we have, that is proof of stake. Otherwise, we can call it as POS. So this is also one of the consensus protocol. Okay, so in this nodes are known as validators. So here there is no proof of work. The miners they are not spending their electricity or bandwidth or storage. So here nodes, the blockchain nodes are the validators. They will verify the transactions. Okay, so they validate the transactions to earn the transaction fee. So in a blockchain network, whenever you are performing some operation, there may be a transaction fee. So that transaction fee will be paid to the validators. Okay. So validators will validate the blocks by placing a bet on it. If they will discover a block which they think can be added to the blockchain. So like they will spend the money on the transactions. Okay, so they will bet their money. Okay, they will spend the money and they will increase their stack. So if it is true, then they will increase the stack, like they will collect the transaction fee. Okay, so like based on the actual blocks added in the blockchain, all the validators get a reward. Okay, so this is the proof of stake. So you need to understand the difference between proof of work and proof of stake. In the proof of work, the miners will use the dedicated hardware and software in order to solve a cryptographic puzzle. Here there is no cryptographic puzzle. So here miners are the validators. The blockchain nodes itself. They will bet on the unconfirmed transaction and they are trying to validate that particular transactions. So after that, they will get the transaction fee for that. So that is proof of stake. So they will pay their money and they will earn a extra money in terms of transaction fee if they will prove that transaction. That is proof of stake. Okay, now let me discuss P2P network. Okay, we will say the blockchain technology is peer-to-peer network. Okay, so what is meant by peer-to-peer? So here blockchain is a peer-to-peer network, so which works on IP protocol, right? So a P2P network is a flat topology with no centralized node. So here this is a decentralized network, so which is not dependent on any central network. Here all nodes equally provide and can consume services while collaborating through a consensus algorithms. Here the P2P networks are more secure because they do not have a single point of failure. Okay, so this is a peer-to-peer network. Okay, so the blockchain is known as DLT, that is distributed ledger technology. So what is meant by DLT? So which uses independent computers to record, share and synchronize the transaction in the network. The transaction details are recorded in multiple places at a same time in DLT. So yeah, blockchain is one type of distributed ledger. Here we can see the properties. So what are the properties of DLT or blockchain? So the blockchain will be having some property like immutable, right? Because the transactions we are storing in the blockchain network then that cannot be modified. Okay, so there is a link. We are going to use the previous hash. So the number of blocks, block 1, 2, 3. So it will be connected with the chain. So if you tries to modify any data in a particular block, that gets reflected in subsequent block. So it is highly impossible to modify the data. Next property we have secure. Okay, so the blockchain is implemented based on strong crypto primitives like public key crypto systems. We have used elliptic curve, digital signature algorithm, as well as digital signatures and hash function, which makes the system, blockchain system, very secure. And the property of DLT, and that is blockchain, is programmable. So not only for crypto transfers, so even we can develop the applications. Okay, that is programmable. We can write the smart contracts. We can write the programs into the blockchain. We can deploy in the blockchain. So the blockchain is programmable. One more property we have distributed. Okay, so the blockchain technology, so it is based on the DLT. It is distributed. Here all the network participants have a full copy of the ledger for full transparency purpose. Then anonymous. Okay, so you consider the Bitcoin network. The users, which ensures the privacy. Okay, so which provides the anonymity, untraceability, and unlinkability. So like anyone can join the Bitcoin network and they can perform the transactions and the details. Okay, so the identity details should not be revealed to any other person. So obviously blockchain is anonymous. And time stamped. Whenever you are performing some transactions, whenever you are deploying the transaction, so that should be recorded in the blockchain with the date, time, everything. That is time stamped. And one more property, last property is unanimous. Okay, so like all network participants agree to the validity of each of the record. All the protocols, all the nodes should take a fair decision. Okay, so during the consensus mechanism. So these are some properties of blockchain or distributed ledger technology. Okay, so let me discuss what are the blockchain types. The blockchain is mainly classified into three types. One is a public blockchain, private blockchain, and federated or consortium blockchain. The examples of public blockchain, Bitcoin and Ethereum; private blockchain, Hyperledger and Corda; consortium blockchain, Quorum and Dragon chain. So here public blockchain is nothing but permissionless blockchain. So here everyone can join the network and they can perform the transaction. So there is no restrictions on the public blockchain. Now private blockchain. So here private blockchain is permissioned blockchain. So only authorized people can join into the blockchain and they can perform the transaction and they can deploy the smart contracts. And one more blockchain type we have like consortium. So two or more organization, say a group of organization, they want to make collaboration and they want to develop blockchain based application, they can go to the consortium blockchain. So this is also one of the permission blockchain. So here we can see the differences between the different blockchains like public, private, and federated blockchains, we have the access. So in the public blockchain, anyone can access the network. So in the private, single organization. In federated, multiple selected organization. About the participants, like in public blockchain, the participants like permissionless, so the participant user details are anonymous. So in the private blockchain, so it is a permission blockchain network, and the known and identities will be involved. So same in federated also. In case of security, in the public blockchain, the consensus protocols like proof of work and proof of stake can be used. In the private blockchain and federated, pre-approved participants and voting based consensus protocols will be used. And the transaction speed is slow, so because many users will be there in the public blockchain network. So here private and federated, later and faster. So here let me introduce some blockchain platforms. The popular blockchain platforms are Ethereum, Hyperledger, IBM Blockchain, Multichain, HydraChain, Ripple, R3 Coda, BigchainDB, OpenChain, IOTA. So these are the top 10 blockchain platforms. Yeah, thanks for watching this video.